Hi there and welcome back. Now, everything I said so far is true, but there are times in which you may just want to write the Laurent series to find out the residue because perhaps it's just easier to do that because you have some really simple function. So I'm gonna be doing just like three examples. I mean, I'm pretty sure that you already know how to write and calculate Laurent series, but it just just worth doing it with a few examples, like three examples in a row, and then going back to what we were doing before. So now, if I ask you what's the residue of the function, I'm going to be doing it for this function. So f of z equal to e to the 1 over z with, so at z0 equal to 0. Now, to do that, we can basically write the series like directly. So we can say that e to the 1 over z is, well, 1 plus 1 over z. I could even stop here, but plus 1 over 2z squared plus on and on and on. And in this case, well, we just have this one. So the residue is just 1. So the residue is 1 with z0 equal to 0. The very same and the very same way, we can say, well, another example, like very quick one. I don't want to spend much time on on writing the Laurent series per se because it's like, well, it happens, but it rarely happens that you have something so simple. So, and you should be already familiar with this. So I don't want to spend much time on it. So if I ask you what's the residue of the function, and the function we have is another fairly simple function, which is z times cosine of 1 over z with z0 equal to 0. Well, in this case, we can once again write the series. So the Laurent series is of z times cosine of 1 over z is, well, we can factorize z, top of everything, and it's z times 1 minus 1 over z squared 2 factorial plus on and on and on. I can stop here. This is the term I want. So 1 over 2 factorial is 2, so because it's 2 times 1, 2 times 1 is 2, so it's negative 1 over 2. So the residue is negative because we have a minus here, 1 over 2. 2 factorial, 2 times 1 is 2, so 1 over 2, with z0 equal to 0. Again, I want to make one last example, very quick. Again, I don't want to spend much time on this. What's the residue of the function f of z equal to z squared times, the sine of 1 over z times the cosine of 1 over z with z0 equal to 0. Well, in this case, we can once again write directly the series. So z squared, sorry, it's not coronavirus, it's just me coughing. Z squared times sine of 1 over z times cosine of 1 over z is equal to, well, I'm going to write the series. So again, we can factor not the z, but a z squared in front of everything this time. And then we have 1 over z minus 1 over z cubed 3 factorial plus on and on and on times, so I got rid of the for d sign, then I have the cosine, which is going to give me, well, 1 plus 1 over z squared 2 factorial plus 1 over z to the fourth 4 factorial, and on and on and on. But I can stop here. So again, by multiplying, I get, well, I'm going to rewrite this first part. So and z squared times the sine of 1 over z times cosine of 1 over z is actually equal to, well, I'm basically going to multiply. I'm going to leave z square alone. I'm going to multiply those. So by multiplying those, I get z squared times, I'm going to use brackets, 1 over z plus, well, this and this, it's 1 over z cubed times 1/2 minus 1/6 plus on and on and on, and get a higher order terms I couldn't care less about. So it's actually 1 over 2 minus 1 over 6. So the residue is exactly this. So 1 over 2, 1/2 minus 1 over 6, which is, well, 6, which is 3 minus 1, so which gives me 2 over 6. I can simplify this with 1 and 3, and it gives me 1 over 3 with z0 equal to 0. So once again, sometimes, almost never, it's actually easier to just write the Laurent series to find residue. And I just wanted to show you that you can do that, but it almost never happens. So yeah, but after this example, I'm going to be talking about how to find the residue, but in the old way. So the way we were describing before. So stay tuned for the part 3, so the example 3.